Hello YouTube and welcome to GrunfWorks. This is Kerbal Engineering, and today I want to be showing the building Karborandrum Particle Collector. The idea of building this ship is, as we have uncovered in our Interplanetary Voyage Series 2, the secrets of the Karborandrum, and our scientists have been able to produce small quantities of it only in the laboratory conditions, also using the cyclotron. So we have decided to actually endeavor on a much more ambitious expedition and collect as much as possible of the Karborandrum, and we will be launching this ship that I'm just launching to the low Sun orbit. So it will be going into the low solar orbit with a mission to collect Karborandrum. Apparently, according to the properties of the Karborandrum, our scientists have uncovered some quantities on the surface of Eve, also on the surface of Eeloo, and in the low Sun atmosphere. Of these three, the low Sun atmosphere seems the most plausible for the ship of the size and unmanned mission which I'm planning to take. So we are designing a ship that will be able to fly on its own without any Karborandrum, so empty of Karborandrum, to the low solar orbit, collect the Karborandrum with the particle collector that I plan to put, and then basically come back on its own drive with plenty of deltaV to spare, hopefully. So I am putting now the middle station component, and on the top I want to be putting the advanced particle collector, and on the sides I want to put the Karborandrum scanner. I don't know if those will work in the low solar orbit, but might as well give them a shot. Yeah, okay, great. Then we want to be putting some lights. And guys, unlike my other ones, this one I will be showing a 3 times time acceleration, but I will be also showing some of the mistakes that I've been making, because the purpose of the engineering series is to show the design process and a little bit of tests, but not really that much. We will be flying this one in the Interplanetary series of exploration, and let me know what you think, guys. I think this is a good way because the more advanced construction that takes a while is taken away from the series. The smaller construction I still keep in the series, while the people that are interested how are these monstrosities being built have their own separate series where they can check and stuff. So, okay, now putting the docking ports, and we have 2 long-range antennas, and now I'm putting the short range, just the one that will be communicating while we are in orbit. Then I want to be putting the 2 RTGs which will be generating power. We already have the battery, so that should be okay. Let's just name it Karborandrum Tanker Mark Sol, because we're going to the low solar orbit. And I just want to see that those aren't crashing with the particle collector. They are not. Great. Okay, then we want to be... I'm just curious in terms of fairings, and let me just try and find some sort of fairing. 3.5, I think it's too small. Yep, because of the antennas. So 3.5 won't cut it, I think, or 3.75 won't cut it, so we'll take the 3.75 expanded. And that one is large enough to fit pretty much all of this ship inside, which is definitely good, so I'm gonna just cover it up. It has to be something believable, something like that. Looks good enough for my taste. Perfect. Now the next thing that I want to take care of, I wanted to have a clamshell deploy. As always, I don't like confetti, really. Okay, then let's see, then we want to put the transfer stage, and with this one I've been experimenting a little bit back and forth, which I plan to spare you some of it. So I'm thinking the Magnetoplasmodynamic engine should be the one transferring this bad boy, but those ones require a lot of electricity, so I have to put some nuclear reactor, and they require also 3.75 meter nuclear reactor, and Magnetoplasmodynamic engine is here, and we also need some fuel, and it requires lithium. So I'm actually trying to find, those are argon tanks, but I'm trying to find lithium, hold on, hydrogen. Oh, I think I found lithium. Great. Those engines are very fuel efficient, but they are very low thrust to weight, and Magnetoplasmodynamic engine is actually a little bit higher thrust to weight, so that one should hopefully provide at least some thrust. 0.33. So we might want a bigger size engine, or two engines to be precise. I want to be my thrust weight roughly 0.5. I don't like it lower than that, because then the burns take forever. Okay, so let's see, lithium, and we have lithium tanks. This seems to be the biggest one of all. So, and I was thinking that there is tweak scale configuration for this, but clearly there is no, so let's see if we can make do with what we've got. I mean, it gives us 6,000 deltaV, which is not enough. We want 12,000 deltaV, so let's see, dual adapter, and I want a double engine, see if we can get this one to 3.75 meter, and the engines are overlapping. No, I don't like that solution, to be honest. So what can we do? Thrust plate, multi-adapter, no. And I have too many parts, clearly. So, I'm actually thinking that I would, rather than that, put some radial decouplers and a bigger size engine. So let me remove this, and let's see, Magnetoplasmodynamic. Can I scale this one up? Oh, 3.75, 0.84. Great! This is actually something that I can work with. Although I have no idea what its power requirements would be. Can only hope that this plasma or this nuclear reactor should be enough to keep it running, which I'm not 100% sure. But okay, now with the two side tanks we have 12,000 deltaV, which is something that I'm planning to do, but we need the decouplers, because I would like to stage them when I no longer need them. So let's see, what do we got? And we have 5, and my staging is wrong, clearly. So I was thinking fuel lines, and well, fuel lines don't help you when your staging is wrong. Duh! So if I flip it, once again I get 12,000 deltaV. Okay. The thing that I don't like at the moment is that since those are too close, they are cutting into the fuel plant or the nuclear power plant and other things. So I would really like to actually pull them out a little bit more. So I was trying to put cubic octagonal strut, but it doesn't seem to be working. So let me try something else. Let me put not the decoupler. Can I put this on top of a decoupler? No, I cannot. I can only side attach. Okay, so let's reverse it. This one. I really don't like this design, so let's put the radial attachment point. Yeah, 2 of these. Then I will be putting this component, 2 of them, perfect. And now I will be attaching the decoupler. So this should give this ship a little bit of futuristic design, but we would still be able to decouple the tanks, which are the main source of weight. So let's see, nose cones, we do want to make them aerodynamic while we're climbing up. I should put maybe the fuel lines, and I would like to put them also somewhat below maybe. Okay. What do we have? Nose cones, let's put them from beneath as well. Yeah, so they're basically drop tanks. Then what do we have? We have heating panel and radiators. Great. Then let's see, what else do we need? We need, well, basically we need the ascent stage, that's for sure. So, and I'm thinking in terms of, I would really like to put the engine like fairing or interstage, so once we decouple, then we expose the engine. Let's put the big ass fuel tank underneath. That's the Spirit. And let's put the, I believe I could put the, I'm trying to find the big suitable drive. It's 5 meter, so I'm looking for the biggest engine that I could find, but then again maybe Rhino or this one. 2.45 and 2.429 meters per second. Should I cram in another fuel tank? Well, it doesn't help out much though. No. We'll need to use the side boosters. Decoupler. And I want to be using the KW rocketry. I really like these side tanks. Okay, now let me find the engines, and I want to put 2 Rhinos. Those should be more than enough to give us deltaV that we need, and also fuel lines so that the fuel feeds into the central stack. Okay, that would give us some boosting power, that's for sure. Let's attach the launch stabilizers or launch clamps. 2 on the side, 2 on the side, and those launch clamps, given that these are KW rocketry engines, maybe should better that those start the moment after, but I need some stabilizers, and I'm thinking first SAS, yes, let's put that one. Then let's put some fins, and I want to be putting them actually here where they're supposed to go. The only trick is that they are swiveled a little bit, so you need to do some convincing. Let's offset the rocket engines a little bit more down. Perfect. And now the fins. Okay, corrected. And I'm thinking of putting the 2 here, or 4 here, and then maybe some here. Those are small fins, and yeah, let's now look the staging, correct the staging, great. How the center of mass and center of lift look like? Oh boy. Center of lift way in front of the center of mass. I don't like it. I prefer to have a center of mass after the center of lift, so let's just strut these 2, then we'll take care of the business. Ooh, and further down. Great. So now these are okay, and maybe strutting these 2 also down to the fairing base would be a good idea, so we don't get the noodle wobble. Great. Okay, so then we want to put 1 communitron somewhere along these lines, maybe here, yeah, here, so that I can easily deploy it and it's not subject to aerodynamic forces. 1 small antenna here as well. 1 will be toggling the communitron, and 2 should be well, maybe not. 2 should be toggling the radiators. Yeah, I think that should be fine. Okay, I'm starting to think, what about the center of mass, center of lift? I might want to add more fins, but at this stage, I don't know, I'm thinking about giving it a test first. So let's simulate. That's why we have simulation 4, guys. So giving it a good old test run. Okay. Throttle to max, SAS on, and launch. Also, this is time accelerated, but seems that we have a good thrust to weight, roughly 2 at the launch, which is definitely desirable. Let's try and keep the rocket angled slightly prograde, or slightly orbit prograde, so going towards the 90 marker. Detaching. Good detach, perfect. They blew up afterwards, but ultimately I don't have to care. And flippity flip flip flip. Kicking the engine, which kicked the bucket equally as fast. Let's do some confetti. Yay! Well, back to the drawing board. Okay, center of mass and center of lift definitely kicking the bucket. I don't like it. Nuclear reactor, so no. Heat management systems, thermal control panels. First things first, I want to attach them also to the nuclear reactor. That's one thing. Because I realized, they need to be cooling the reactor, not the fuel tank. So, that thing fixed, we need to fix also the aerodynamic forces that are building up. I'm thinking let's press simulate. Or, by the way, guys, as you can see, I have added the B9 winglets, and I replaced the large fins with these winglets because they are significantly higher lift, and they should hopefully provide good center of mass and center of lift balance. So that's the idea anyway. Okay, and yeah, I think now we can kick the simulations. I skipped adding these because I added them as a mod, and this is a part of B9 Legacy. So, hitting it. Oh, dancing a little bit, but we still have 1.90 to 2 thrust to weight. Climbing steadily now. We want to test also the aerodynamic stability and also all the subsequent stages of the mission. So, detaching, great. Still at thrust to weight 2.55, which is awesome. Okay, going up. And we have Apoapsis high enough. So Apoapsis is roughly in the hundreds. This is great. And let's just circularize. Okay. Circularization burn setup, okay. Okay, so the rocket is still climbing. We are at 84 meters. Let's deploy the radiators, deploy the antenna. And I want to be activating the reactor, just to make sure that the reactor is stable, not overheating. Okay, lining up with the burn. 1900 to burn, and we have 1400. So we will be finishing the circularization on our magnetoplasmodynamic stage, which is leaves something to be desired, but let's give it a try anyway. Okay, stage. Ooh. Wow. Back to the drawing board, I guess. Okay, so, decoupler enables staging or not? Force percent, let's put it much slower. Maybe 20 or something, because basically when it went up, it just cut everything along the way. So let's start. We know already that the scent profile works. Let's just test how it works. Decouple, and it comes, bumps, but still looks okay. Okay, let's kick the lithium engine a little bit. Okay, that sounds much better. Deploying the panels, starting the reactor. So the reactor does start. Let's kick the engine and ooh, yeah. Okay, let's see. We have available power. And the generator is kicking up to the... generator should be going up to 3000 electric charge per second, if I'm not mistaken. Or even more. But the engines are also power hungry. Very power hungry. Yeah, the generator is going around 4000 electric charge per second, but still that's not enough to throttle the engine at full throttle, and we only have the thrust to weight 0.60, and now we have we have consumed everything, and we are stuck because all the deltaV goes to maintaining the engine, and we cannot even control the craft because we lost all electric charge. Okay, this is gonna be fun. I think we need another redesign. So, I have replaced one big nuclear power reactor with 3 NearFuture electrical ones, as you can see here. So, then basically I took 3 of these MX2 flat fission reactors rather than one big from Umbra Space Industries. Those should provide sufficient thrust. Now, I would also like to remove this interstage, and I'm thinking I would want to know how much this one takes, but I don't know. So instead I'm gonna put 2 magnetoplasmodynamic engines here, and I'm gonna put decoupler somewhere along these lines. Maximum thrust to weight 0.5, and I think I'm gonna go with that. I have to reverse the fuel lines because the fuel lines now have to feed into these 2 tanks. Great. And then we have to figure out a staging decoupler. So decoupler 2.5 meter, and then we can add some more actually fuel adapter here, which would give our basically ascent stage a little bit more juice. So that gives us a total of 3.4 thousand, which is definitely good. And it puts us, yeah, I think this should actually do it. Then again, if I put 4 of those, it should be even better. Because then all of the fuel feeds in, and we have a total of 4,172, which is definitely not bad at all. So we want to have an onion staging, not asparagus one. So we will be definitely decoupling those in space already, hopefully. or not actually 1600. Well, yeah, no, not really. But okay, at least I think we should have more than enough to actually circularize, and because I don't want to be circularizing on magnetoplasmodynamic engines due to their so low thrust to weight. Okay, I still want to put more stabilizers on this just to make sure that, well, we are stable enough. Great. And I think it's should be time for another simulation, I guess. Let's final checkup. Yeah, I think we're good. Thermal control system. I might actually put 2 more. Just to be on the safe side, we do want to keep those 3 reactors cool. Okay. Let us yeah, I think now we're ready. So let's go forward with the simulation now, shall we? Oh, I also wanted to put the panels and number 4, the antennas, also on the action group, so it becomes easier to actually control it. Cool. Now launch, and I will be once again launching from the launch pad rather than from the high above Kerbin, because I do want to test. Now I have changed the launch configuration, so I want to see that that one is also running well enough. Okay, kicking the gas. So far 1.87, a little bit lower on the thrust to weight initial one, but still going very nicely, going stable, that's for sure. Angling rocket already at 2000 meters. We are going higher up, and I'm thinking raising our periapsis. I do want to keep a slightly steeper profile because of we are having 4 boosters which we will be detaching. 450 meters per second. We have passed the sound barrier. Our Apoapsis is already in the 30s. $700 meters, so 800 meters per second. Detaching. Oh, some explosions, but our center stack still survives. So okay, I guess that's acceptable. Maybe not from security reasons, but from Kerbal reasons, surely. Okay, and cutting the gas because we are at 101 Apoapsis. Now it's time to prepare the circularization burn. Add the Apoapsis, so let's see how much that would take. Roughly total deltaV of 1904, and we have total of 2.1 thousand of meters per second of deltaV, which I think it's exactly how much I wanted to have, so that we could circularize and have a little bit extra, but those extra we won't use, I guess. So, beautiful view. Okay, and in 5, 4, 3, 2, 1, and kicking the gas. Time to circularize. Beautiful screenshot. (1,000 meters per second to burn). Okay, Time to decouple the last stage, and I'm just gonna use a little bit of the energy because we are using our batteries to propel it, so I want to first expand the radiator panels, after which I do want to turn on the nuclear reactors and then start the engines. Okay, let's just go a little bit around the globe. So let's see. Okay, we do have the sunlight, not that we need it, but let's deploy the fairing. Let's assign the long-range communication dish and open it. Great. Okay, and now we do want to turn towards the sun, and then I realize I don't believe I have SAS at all. So I'll have to test it as is. Activating the reactors. Okay. And let us slowly but painfully turn this bad boy around. I am using slight thrust from the engines, not much. 0.06 over 0.52 just to turn us, and then I will be kicking the gas. And I also want to align a little bit, rotate to make it look a little bit more cool. Something along these lines, and then kicking the gas. Bam! And it seems that our generators are producing a sufficient amount of electric charge, and we do have 0.5 meters per second, which is great. We could even close down these two, and I think I'm gonna remove them from the final design, guys, but I think this ship looks pretty cool, and it has definitely enough juice to get to the low solar orbit. It will just take a long burn to actually get there, but yeah, well, the good thing about it is that we are not making a Hoffman transfer anywhere, we're just burning retrograde from the actual orbit. Let's test the decoupling, extracting the solar panels, and well, now we should also add the particle collector, and then that should complete our tests. I'm actually pretty happy with the way it looks like, so I don't think this should be an issue. So I will remove the last two panels, and I do want to be putting some SAS, just not to shoot myself in the foot later. SAS and one SAS 3.75 here to make it easier to turn. Come on, please, please. Yep, this looks good. Okay, I think that should be enough. Maybe one here just for the upper stage as well. We do want to have SAS authority on every stage separately. Great. I think that should be about right. Let's put some separatrons on the ascending stage, because if you remember, those rockets were blowing up for some reason, and I don't want them to be blowing, so yeah, some separatrons, just to make sure the side boosters go into the right direction. Then the separate one, and they need to fire when we stage our boosters, so I think that should be fine. We just put them here. Great. Checking the rest of the staging. We do want the staging to be here earlier. I think that should be fine. Yeah, okay guys, we're coming up on the end of this episode. Like if you like the episode, hit subscribe for more KSP content that should be coming soon, and I guess until the next episode, thank you very much for watching, guys. This is GrunfWorks signing off.